Welcome to my videos. Today I will explain you about some features about the AVR microcontroller. AVR microcontroller is used in the many industries now. I will explain you one very important information about AVR microcontroller. Is the 8-bit microcontroller. If any one person asks with you that how many bits of AVR microcontroller, then you have to say, give the answer of my AVR microcontroller is the 8-bit microcontroller. This chapter begins with a discussion of the role and importance of microcontroller in everyday life. Everyday life means that in everyday life there AVR microcontroller have some importance. In this section, I will also discuss criteria to consider in choosing microcontroller as well as the use of microcontroller in the embedded market. Section 2 covers various members of the AVR family and their features. In addition, we provide a brief discussion of alternative to the AVR chips such as the 8051 PIC and 68HC11 microcontroller. Section 1 microcontroller and embedded processors. Now we will discuss about section 1 embedded processors. In this section we discuss the need for microcontroller and contrast them with general purpose microprocessors such as the Pentium and other 8586 microprocessors. We also look at the role of microcontroller in the embedded markets. In addition, we provide some criteria on how to choose a microcontroller. You will look at this. The block diagram says that general purpose microprocessor system and microcontroller: CPU, RAM, ROM, input and output, ADC, timers, serial, COM part, data bus. First is the CPU, general purpose microprocessor, data bus, RAM, ROM, address bus. This is the data bus. This is the address bus. These are the components, and all of the diagram is says to be the general purpose microprocessor system. Now come at lower side that this is the microprocessor has CPU, data bus, address bus, RAM, input output ports, timer, serial comms, and microcontroller has CPU, RAM, ROM, input output ports, timers, and serial COM parts. Both are similar. Figure number 1 says that microprocessor system contrast with a microcontroller system, but there is there is same things, but you have to say focus. This is the input output ports, and there is input output ADC. Now figure number 1 says that microprocessor system contrast with a microcontroller system. Microcontroller versus general purpose microprocessor. What is the difference between a microprocessor and microcontroller? By microprocessor is mean that the general purpose microprocessor such as Intel's 86 multiply by 86 family, 8086, 286, 803, 86, 804, 86, and the Pentium are Motorola Power PCs families. These microprocessor contains no RAM, no ROM, and no input output ports on the chip itself. For this reason they are commonly referred to as general purpose microprocessor. This is a very important thing you will mention here, that there is a difference between a microprocessor and microcontroller. By microprocessor is mean the general purpose microprocessor such as Intel 86 families, 86 Intel's multiply by 86 family, 8086, 80286, and Pentium are Motorola Power PC family. These microprocessors contain no. Now look at this. Some important key I will explain you. This is a highlighted key. General purpose microprocessor. General purpose microprocessor. General purpose microprocessors. General purpose microprocessor. General purpose microprocessor is that these microprocessor, this microprocessor contain no RAM, no ROM, no RAM, no ROM, and no input output ports, and no input output ports on the chip itself. On the chip itself. For this reason, they are commonly referred to as general purpose microprocessors. See figure number 1. The system designed using a general purpose microprocessor such as the Pentium or the PowerPC must add RAM, ROM, input and output ports and timers externally to make the functional external. Although the addition of external RAM, ROM and input output ports make these systems bulkier and much more expensive. They have the advantage of the versatility, enabling the designers to decide on the amount of RAM, ROM, and input-output ports needed to fit the task at hand. This is not the case with a microcontroller. A microcontroller has a CPU processors in addition to fixed the amount of RAM, ROM, input-output ports, and the timers all in a single chip. Now we have to discuss a microcontroller has a CPU. A microprocessor in addition to a fixed amount of RAM, ROM, input outputs and timers in a single chip has a CPU. Microcontroller has a CPU. Yes, this is the very important line which comes into many jobs, that a microcontroller has a CPU. A microcontroller has a CPU. You focus on this line, that a microcontroller has a CPU. And what is CPU? A CPU is a microprocessor. Yes, as a CPU is a microprocessor in addition to a fixed amount of RAM, ROM. In addition, you will add it in addition to a fixed amount of RAM, ROM, input output ports and a timer and a timer, all on a single chip. In other words, the processor, RAM, ROM, input output ports and timers are all embedded together on one chip. Therefore, the designer cannot add any external memory, input output or timers to it. The fixed amount of on chip RAM, ROM and number of input and output ports in microcontrollers makes them ideal for many applications in such cost and space are critical. The AVR microcontroller. Now we will discuss about a AVR microcontroller in many applications. For example, TV, remote control. There is no need for the computing power of a 486 or even on 8086 microprocessor. In many applications, the space used, the power consumed, and the price per unit area much more critical considerations than the computing power. These applications most often require some input output ports to read signals and turn on and off, turn on and off certain bits. For this reason, some call these processors 168, 182, 180, 185, 1 IBP, 80 processors see good things in small packages are generating big product opportunity by Rick Graham, Byte Magazine, September 1994, HTTP, for an excellent discussion of microcontroller. It is interesting to note that many microcontroller manufacturers have gone as far as integrating an ADC, analog to digital, digital converter, and other peripheral into the microcontroller for embedded systems. In literature discussion microprocessor, we often see the term embedded system. Microprocessor and microcontroller are widely used in embedded system products. This is a very important MCQ, that the microprocessor and microcontrollers are widely used in embedded system. Microprocessor and microprocessor and microcontrollers are widely used in embedded system product. Are widely used in embedded system products. Embedded system products are widely used in embedded system products. Simulation the microprocessor and microcontroller are widely used in embedded system products. An embedded system is controlled by its own internal processor, internal microprocessor or microcontroller, as opposed to an external controller. So typically in an embedded system is controlled by its own internal microprocessor or microcontroller, as opposed to an external controller. The embedded system is controlled by its embedded system is controlled by its own internal microprocessor, by its own internal microprocessor or microcontroller, or microcontroller by its own microprocessor or microcontroller, as opposed to an external controller, external controller. Typically in an embedded system, the microcontroller RAM is burned with the purpose of the specific functions needed for the system. A printer is an example of an embedded system. Printer is an embedded system. There is one important MCQ about the printer is an embedded system. If anyone job is comes that which thing is the embedded system? Printer is the embedded system, because the processor inside it performs one task only, namely getting the data and printing it. Contrast this with the Pentium based PC or any or any 86 pieces, which can be used for any number of applications such as word processor, printer, servers, bank tellers, terminals, video game player, network server, or internal terminals. A PC can also load and run software for a variety of applications. Of course, the reason our PC can perform my rates task is that it has RAMs, memories, and an operating systems that loads the application softwares into RAM and lets the CPU run it in an embedded system. Typically, only one application software is burned into ROM. In an embedded system, typically only one application system is burned into ROM, and 86 pieces contains are connected to various embedded products such as the keyboards, printers, modem, disk controllers, sound card, CD-ROMs, drivers, mouse, and so on. Each one of these peripherals has a microcontroller inside it, and that performs only one task. For example, inside every mouse, a microcontroller performs the task for finding the mouse positions and sending to the PCs the stable embedded system. Now I will explain you the AVR microcontroller semiconductor. Choosing a microcontroller, there are 5 major 8-bit microcontrollers. They are free scale.